Hello everyone, it's Samir here, and today we are going to look at a problem which is similar to the last problem we posted. Okay, so this is a very normal and simple problem which I think most of you should be able to do it. But the reason for selecting this one is just to show you a new approach or a less common approach in which this can be solved with just, one or two lines. Okay, so let's read the problem. Two mutually perpendicular chords are drawn from the vertex of parabola y square equal to 4ax such that their lengths are 8 and 27 respectively. Find A. Okay, so as for most of the problems in geometry, for this, first what we need is a basic diagram. Okay, so we draw a parabola, a standard parabola that is given. Okay, we assume that it has two chords at 90 degree. Okay, this one and this one. And suppose the length of this one is 8 and 27. Okay, so one of the approaches in which most people, uh, solve this problem is by taking this point as T1 and this point as T2, okay, as the parameters, okay. And then what they do is you can find this distance. You will get one equation in A and T1. Then apply distance formula here. You will get one equation in A and T2. And then you can put the multiplication of slopes of these two lines as -1. So you'll have three variables out of which you need to find A. Now, a better approach to this problem, as with most of the problems which involve distance from origin, is to take the polar form. So we take the polar form of the first endpoint of chord on parabola. Its distance polar form is r cos theta comma r sin theta of any point. Here r is already given to us distance from origin as 27. So we take this point as 27 cos theta comma 27 sin theta. Okay. Now the other part you are getting by rotating this chord by 90 degree. Okay. You are rotating this by 90 degree and changing its length. So the length of new chord is 8. So we put 8 and its angle is theta plus 90. If the angle of the first point is theta from positive x-axis, the angle of second point will be theta plus 90. Okay, so this point will come as 8 cos theta plus 90, comma 8 sin theta plus 90, which will be minus 8 sin theta, comma 8 cos theta. We're just solving cos 90 plus theta and sin 90 plus theta. Now we don't need to do anything else. Just put these 2 points, okay, which lie on the parabola, this one and this one. We just put these 2 points on the parabola because they should satisfy the given parabola. Okay, so we put the first point 27 sin theta. Okay, 27 sin theta in y, so 27 square sin square theta equals to 4a. In the place of x, we put 27 cos theta. Now we put the second point again in the equation of parabola y square equal to 4ax. Its y is 8 cos theta, so 8 square cos square theta equals to 4a and x is minus 8 sin theta. Now, the only thing left in this problem is eliminating theta out and finding a for this problem. For that, what we do is we divide the second equation from the first equation. So, if you divide this 27 and 127 from here will get cancelled out. Similarly, this 8 and 8 from here will get cancelled out. And when you divide, you will get tan theta as minus 2 by 3 because you are going to get sin square upon cos square as tan square, and then 27 by 8 equal to, you will get minus cot theta. So we'll multiply cot to the other side, so it will become tan cube theta, which will be minus 8 by 27. So we will take cube roots, which will give us tan theta as minus 2 by 3. So from this tan theta, we find the values of sin theta and cos theta, and substitute these values in either of the equation, either in this or in this. Now what we do is we put the value of this sine theta and cos theta in this equation, and we will get, okay, 8 cos square theta would be 9 by 13 equals to 4a. This 8 gets cancelled out, so I wrote only one 8 here. And sine theta here is minus 2 by root 13, and another minus of this minus 8. Okay, so minus minus gets cancelled out. 4 twos is 8, and 8 gets cancelled out, and root 13 gets cancelled out, and you get root 13 here. So the value of a that you are getting is 9 by root 13. This will be your final answer. Okay, so you just multiply. The same calculation is shown here. Okay, this calculation is shown for the substituting sine theta, cos theta in the first equation. Here also you will get a as 9 by 30. So the main crux of this problem is, in most of the problems in which the distance from origin is involved in some way or the other, polar coordinate helps us a lot in reducing the calculations as well as solving the problem in more elegant and faster manner. For more such problems as well as unique and new approaches to solutions, keep watching further videos. See you in the next class.